Hello there. Welcome to K nearest neighbor algorithm. Before I take a deeper dive in KNN algorithm, let me take you through a very important distinction between different algorithms, and that's parametric and non-parametric models. You have already gone through simple linear regression, multiple linear regression, and polynomial linear regression in previous lectures. And one behavior you must have noticed is they all have an equation to follow, and based on that equation they derive the dependent variable y. So that is parametric equation. There is already a formula which they follow, and the training data set is fit in that formula. Coefficients are derived, and based on that coefficient the equation is complete, and the rest of the data like test data or future data is put on that equation, and based on that the y is derived. That's how parametric models work. Then there are non-parametric models. Non-parametric models do not have any such equation. They analyze data behavior, and based on that behavior of the data they predict the dependent variable. So that's the difference between parametric and non-parametric models. The KNN model is non-parametric model. That means there is no fixed formula or equation which they follow. Very good. Now that you understand that KNN is a non-parametric model, let's understand how KNN works. So let's say you are running a marketing campaign, and based on certain parameters, certain features of your customers, maybe age, male or female, their location, their family income maybe, and based on that you have found out a behavior, whether they purchase your product or they don't purchase your product. So whether it is yes and no. And if you plot a graph, this is what you get: all the yes points, all the no points. Now consider there is a new customer, new person on social media or wherever you are running the marketing campaign, and you have to predict whether this person will buy your product or not. So basically you have to predict where does this point, this data belongs. Does it belong here, which is yes, or does it belong here, which is no? How will the algorithm know where should this point belong? And that's where the KNN algorithm comes in picture. The way KNN algorithm works, it decides the size of this point based on its neighbors. But the question is, how many neighbors you want to consider? And that is the K value. For example, if I say I want to consider 3 neighbors around it. So let's say these are 3 neighbors. And then majority leads the decision. In this case, there are 2 points on the yes side, 1 point on the no side. So this point will become S. That means that customer you are analyzing, he is going to purchase your product. That would be the prediction. What if I change this K to 5? The prediction changes, because now there are 3 points on the no side and 2 points on the S side. Now this point becomes no. That means the prediction is this customer is not going to purchase your product. So based on the K value, the prediction changes. There is a logic to be followed to derive this K value, and you will learn this while we will go through hands-on project in next lecture. There is another thing to consider. We tell the algorithm to consider K as 5. But how will algorithm know which neighboring points to consider? K is 5, so that way it will consider 5 neighboring points. But which neighboring point to consider? Which of these points to consider? Should I consider this, and these 5 points? Or should I consider these 5 points? Which 5 points to consider? And that's where the logic of calculating the distance between this point, the predicted points, and the neighboring point comes in picture. There are 3 distinct logic available to consider this distance. First one is Euclidean distance. it will take x1 of this point with the x1 of the neighboring point, find a difference, square that difference. Similarly, y1 of this point and y1 of the neighboring point, and it will take a total of that. It will do that for each of the values here, and for whichever combination it finds this value as the lowest, that is the combination of 5 neighbors it will consider. So obviously in this case it will find that that total and the square root of that total will be lowest for this combination. So consider how much computation it has to do. It has to first find the difference for each of the data point, and then it has to find that unique number of points based on the k for which this distance is lowest. That much calculation it has to do to get to the correct neighbors, and that's why selecting k is very important role in KNN algorithm. And of course you will understand that when you do the hands-on project. For now I think you know how this whole KNN thing works, how it calculates the distance, how it finds out which neighbors to consider. So this is one of the logic to calculate the distance, Euclidean distance, and there are several other logic like this one, KB safe distance and Manhattan distance. KB safe distance is maximum of the absolute values, and the Manhattan distance is the total of the absolute values, the difference. Okay, awesome. I think you understand KNN now. I will see you in next lecture. Hello there, welcome to this lecture. Congratulations on completing the simple linear regression, multiple linear regression and polynomial linear regression. You would have already noticed that I have the same notebook open. So we're going to continue using the same notebook, same data set, and we are going to enhance the R2 score, basically our prediction, by using another algorithm, and this time it is called K nearest neighbor regression algorithm. K nearest neighbor algorithm is used for regression as well as classification. And over here in this case we have a continuous data, so we are going to use the regression analysis to predict the MPG value. I'm going to call it KNN henceforth. Before we start KNN algorithm, let me do one more thing. We finished our previous lecture here where we compared the R2 score of MLR and PLR. Let us enhance this. Let us add root mean square error to this, because that is another criteria we should compare. Sometime root mean square error is more important than R2 score. So that's why let us add that and compare both of them. So let's do that. So first we are going to import from sklearn dot metrics import mean squared error, and we will also need from math square root sqrt. Very good. We already got print R2 score. Let us print root mean square error for MLR, and that is going to be square root of, put comma here, square root of mean squared error of these two values. Likewise, so that's for MLR, and likewise do the same thing for PLR. In case of PLR it will be y plot, y polypret. Okay, here we go. So we got R2 score and root mean square error for MLR, let's say PLR here. So there is an improvement in R2 score as well as root mean square error. Very good. Now we can begin the KNN algorithm. We're going to use the same data set and we will see if there are any improvements by using KNN algorithm. To use KNN algorithm, we need to first import the KNeighbor regressor method from sklearn library. From sklearn .neiggbor neighbors import KNeighbors regressors and then create an instance for KNN neighbor regressor method. KNN equal to KNeighbor regressor and just create a instance of that. Over here we will put n neighbors equal to 9, and don't worry, I will explain you what is the significance of that value and why do we choose 9. For now just put the n neighbors equal to 9, and next we are going to fit the KNN with the x train and y train value, x train and y train. Okay, so we got the model, we got our KNN model fit. Let's run this. Looks good. And next we're going to predict the y value. Now let's say predict y underscore pred KNN equals KNN dot predict, and here is going to be x test. Very easy, right? Awesome, we got y predict values. Next we're going to compare the actual versus the predicted value. That's right here. Let's do df3 over here. 18 15 15 14 18 15 16 15 15 13 14 looks pretty good to me, but how do we ascertain that this is better than the last one, the previous one? Remember, the first thing we are going to do is create the scatter plot, extend this scatter plot. Let's do that. Okay. plt dot scatter x and y, in this case is going to be predict value is going to be this, and I'll pass x, and color of these points, let's say I'm going to say yellow. Good job. Let's see. Wow, I think this one, the yellow dots are more closely aligned with the actual values, the blue dots, compared to the green curved line which was for polynomial linear regression, and the red straight line which was for multiple linear regression. Let's run our numbers. Let's run our R2 score and root mean square error, and let's see if there are any improvements in that, right? So let's do that. Okay, let's see here. PLR, and then here we will say KNN, and KNN predict x, very good. Let's run this. Okay, now let's compare. So R2 score, of course there is a improvement. In case of PLR it was 0.68, in case of KNN it is 0.75, and at the same time root mean square error has gone down from 4.3 to 3.88. So this is definitely an improvement. So KNN is giving us a better prediction model than MLR or PLR. So congratulations, you are moving in right direction. One thing I want to point out, if you look at this KNN, it's not a straight line, and that's why it is not called linear regression. Linear regression is simple linear regression or multiple linear regression or polynomial linear regression, which actually gives you a line, either it is curved line or straight line. But in case of KNN, because it is based on the nearest neighbor points, it's not a straight line. It just predicts the y values based on the nearest neighbor points, and this is why it looks like a scattered plot in line with the actual points. And maybe that is why it is giving a better prediction in this case, right? So you are moving in the right direction, my dear friend. Now you are becoming data scientist. Now you know when you get a data, how to play around with it and how to get better and better in your prediction. But before we conclude, remember I was talking about this neighbors equal to 9, and I told you that I will explain you about that. In the concept phase, you already understand the k-neighbor algorithm works based on the neighbors. Like if I consider a point here, it is based on where are the neighbors, and it calculates the distance between that point and the neighbor, and then it decides, okay, where does that point belong. The number here is telling the algorithm how many points you should consider as neighbor. So if I give 9, that means the algorithm is going to consider 9 points in its neighborhood. So it will consider 9 points and it will come up with the predicted values. You can start with the 1 and go on, but the way KNN neighbor algorithm works, the root mean square error here becomes very high if k value is low. But it does not mean that if you keep increasing k value, this will keep going down. There is an optimum point you have to understand. And how did I come up with this number 9? Let's go through that. So I will explain you how did I come up with the number 9. It's very easy. We just have to write few lines of the Python code and we will understand. So let's say for k in range 20, we will run the same logic like predicting the y value, but instead of just passing n neighbor as 9, we will pass n neighbor from number 1 to number 19 and see how overall the square root mean error is changing. So let's do that. K equal to k plus 1, and then just copy the same thing here. And then y pred, and let's print k value, which is this here k, and then RMSC, and RMSC is right there. Very good. Let's run this. So for k value 1 is 5.8. It starts at 5.18, the highest value. Then it keeps going down. Look at this, keeps going down until the 8 and 9, and then it increases after that. So if I plot a graph of this, it will be clearer. So let's plot a graph. Okay, for plotting the graph, I need all these error values in some NP array. So let me create a empty array first and then add these error values in that. Okay, let's see, I have all those values. Yes, I got those values. Now I can draw the plot. Let's say curve plot equals pd dot data frame RMSC, and then just curve plot dot plot. Here you go. It started with more than 5.5 here, 5.8, right? Kept going down with the k value from 2.5 goes down, and then after about 8 or 9 it increases again, right? So you can choose either 8 or 9, and that's the optimal value for this. I went for the 9. So that's how you get the optimal value for k to use in KNN algorithm.